Good afternoon. So hydrogen has been touted for a long time as an energy carrier of the future. And my boss, Brian Kalk, asked this question: has the time for hydrogen arrived? So we're going to spend a few minutes talking about hydrogen and its role in our energy economy. So first, just a little background on what hydrogen is. It's an odorless, colorless gas in its natural form. It's the most simple element. It's the first one in the periodic table. If you remember back to your chemistry class, it's that first box in the upper left-hand corner with one proton and one electron. You ask a chemical engineer in a talk, he's going to have to talk about the periodic table at least once. I think somebody's going to show one later. I didn't have it in me to stick it in the slides. It's also the most abundant element on Earth. It doesn't exist in a natural form really at all, right? It's not the sort of thing that you can mine or harness or extract like we do most of our primary energy sources. But it is prevalent, right? It exists in the molecular structure of lots of familiar materials. And so the pictures on the right side of this slide kind of show some of those. There's a lot of hydrogen in ammonia and in natural gas and in coal and biomass. More hydrogen elements, atoms, than any other element in those molecules. So it's ubiquitous, right? Wherever you are on this planet, there's going to be a source of hydrogen available to you. But you also need some energy to be able to extract it from that molecular structure. Probably the most important thing about hydrogen, relevant to our discussion today, is that when it's used as an energy carrier to extract the energy out of hydrogen, once you have it, you either burn it to produce heat and power or react it in a fuel cell to generate electricity. And the hydrogen reacts with oxygen in the air to produce water, and that's really its only emission. So through that mechanism, you're able to generate the energy that you need and eliminate all of those end-use emissions that come along with it. So that brings us to why hydrogen. Why do we care? The primary reason is the one that I just stated, the ability to use this energy carrier and get rid of all of those downstream emissions that come along with it. But hydrogen isn't a silver bullet, right? And it's not going to replace all of our energy resources, right? It's an energy carrier. It's going to rely on all of those other sources of energy in order to produce that hydrogen product and then use it in whatever its downstream application may be. So quite the opposite, right? Hydrogen is an energy carrier. It's an enabler. It allows us to capture energy from all of those primary resources and then use it. So on the right side of this image are a number of uses for hydrogen. The primary use today is in the production of transportation fuels. So petroleum refining, renewable oil conversion to renewable diesel or jet fuel, and then industrial applications like chemicals, steel manufacture, ammonia is a big one. It's typically produced at the point of use. So you generate hydrogen, react it to form whatever products you're trying to make. And most of that production is coming from natural gas reforming. That's by far the largest source of hydrogen in the US today. On the left side is the hydrogen production processes, right? So it's kind of broken into two categories. On the top, you've got different sources of electricity, and it doesn't matter where the electricity is coming from, but once you have a source of electricity, you can feed that to an electrolyzer, and the electrolyzer effectively decomposes water into its elements, hydrogen and oxygen. So it produces a nice clean hydrogen stream. The other pathway, whoops, wrong one. Let's try this fuel-based production. Basically, that's a thermochemical conversion of a variety of resources, all of those things that contain hydrogen, whether it's biomass, coal, natural gas, etc. You can thermally decompose those materials into a syngas, primarily hydrogen. You separate that hydrogen stream out, and that becomes your energy carrier. So today we have quite a bit of hydrogen production in the state already. Lots of hydrogen is produced and used. A couple noteworthy facilities would be Marathon's Mandan Petroleum Refinery to make transportation fuels, their Dickinson Renewable Diesel Facility. They're using natural gas to produce hydrogen to produce transportation fuels. Dakota Gasification is another good example where they're gasifying coal to produce a hydrogen stream that's then used to make synthetic natural gas and ammonia, which are then sold regionally. Ideally, we'd like to expand the hydrogen use beyond those existing industrial sources, allow us to put to use more of our energy resource, produce more hydrogen product that can either be sold on its own merit regionally or exported, and also use that hydrogen to produce more value-add products in the state, especially in areas where we have high demand, like fertilizer, for instance. Ideally, by doing this, we can stimulate some additional demand for Wocken natural gas, being currently the most predominant and lowest cost source of hydrogen. Being able to take more Wocken gas, convert it into hydrogen to create new value-add products could help ensure longer-term oil and gas production and growth in the state while also reducing some of the congestion in the natural gas transport pipeline system. So there are a lot of incentives and some recent federal legislation that is providing some important leverage to kind of kickstart this hydrogen energy expansion. In November of 21, the IIJA, or the Bipartisan Infrastructure Law, was passed, and it allocated $8 billion to create regional hydrogen hubs, specifically to the Department of Energy. So the ERC, with our partners Marathon Petroleum, TC Energy, and Xcel Energy, submitted a proposal, and in October of last year, 23, and this has been going for a long time, we were selected for an award. And we are currently going through the negotiation process to get from that, working out all of the details, basically, of our proposal to get a contracted project to start what will be a $4 to $5 billion hydrogen energy infrastructure project in our region. So the goal of this hydrogen hub is to create a complete supply chain for hydrogen. So production, infrastructure, and use. Recognizing that we have technologies that can produce hydrogen, but few users other than the industrial sources that we already talked about. So a big part of the DOE's effort is to try and spur more end use to stimulate more production and vice versa, and kind of break that chicken and the egg cycle. So the hub, as it currently configured, consists of this complete supply chain for hydrogen in about 3 projects. Hydrogen production will be coming from natural gas reforming in North Dakota, and then in South Dakota and Minnesota, electrolysis of water using available electrical resources, primarily looking at wind, solar, and nuclear in those 2 locations. Hydrogen infrastructure, pipelines, trucking to transport the hydrogen from wherever it's produced to wherever it's being used. And then hydrogen end use is primarily focused on ammonia-based fertilizer production, blending hydrogen into natural gas pipeline to support heat and power generation. And then lastly, those industrial uses that I mentioned earlier, hydrogen to support transportation fuel production. Those are the near-term opportunities. They're demands for hydrogen that exists today. So it's a way to feed into that existing demand with local supply and hopefully catalyze some more growth in hydrogen energy just across the board. So with the investment of those partners and the Department of Energy, we're hoping to continue to support North Dakota's energy production, create new demand for Wocken gas, and it really puts us at the center, us, the ERC, the state, the region, at the center of a really exciting clean energy initiative. So thank you for your time.